very interesting equations to look at today. There's always, the really interesting thing is these kinds of things are what you're going to see in calculus all the time, and yet, and yet, in our college algebra book and in my pre-cal book, there's like literally I can count on one hand the number of times these equations come up, and yet it happens a lot in calculus. So I do want you to, remember that we talked about this. All right, so we want to solve x to the 1/2 equals 5. This is just a sort of a refresher what we did last week here. What does, can you refresh my memory, x to the 1/2 mean? Square root of x equals 5. Yeah, so this would be another way to say the same thing. And then, so how can we basically get rid of the radical? Square both sides, sure. Now, the reason we like exponents, and in this case, these are called rational exponents, rational fractional, it's because our power properties work so famously, okay? The reason that the square root of x squared, the reason that the square and the square root cancel out is because of our exponent properties. So when we multiply 2 times a half, 2 times a half is just 1. So we happen to get x to the first equals 25. Okay, so now with that in mind, how am I going to do something like x to the 3/2 equals 8? So you're telling me I could write it as the square root of x cubed. I could. Is that helpful to you to write it that way? Noah, what are you thinking?
Can't you just square it as is?
So you're saying, okay, so could I square both sides right now?
Yeah, and then you get 6 over 2, so you get x to the 3rd equals.
Okay, so yeah, x. So if I square both sides, the times by 2, 3/2 times 2 is just 3, equals 64. And then cube root it. Yeah, you could cube root it. Yeah, so I could take a cube root of both sides.
I did something crazy.
The cube, you did. What did you do?
Wait. I don't know if this is correct, but I put like the x under a radical index of 3.
X.
Is that just wrong?
Yeah, that would be wrong. Yeah. So okay, so I like what.
Oh wait, I see what.
I like what Noel said about squaring both sides. That was very cool. That gets rid of that denominator. So my question was, if I squared it and then ultimately ended up taking a cube root, could I do both at the same time? Square it and then take the cube root. Ah, okay. So here, all right. So here's what we can do. Anytime we're solving these rational exponent equations, we are technically just raising it to the reciprocal power. Okay, so this is 1/2. The reciprocal is 2 over 1. Here, the reciprocal of 3/2 is 2/3. So solving these, we get x to the, what is 3/2 times 2/3? 1, yeah, x to the first. And then 8 to the 2/3, well, that's the cube root of 8 squared. What's the cube root of 8? 2 squared equals 4. Okay. All right. So kind of interesting. But this is how, like, you guys are great at just trying stuff and working through it. All right. And I think that's really cool. And when you do that a lot, then you realize that, oh, maybe we can shortcut that even more. Okay? So here we go today. Doing a lot of different things today. Example 1. Solve each equation. We are solving each equation for all of the solutions, real and imaginary.
We have the answer by
We have 4 accidents. Y'all have.
Wait, you just said that.
Oh, you're just like.
I do.
All right.
We're doing cubes. Like,
I have a.
This is kind of a bad.
didn't you just say 9 is not equal to this? Is that Friday?
9 does not equal negative.
I mean, square root.
The square root of 9 does not equal plus or minus.
I know what it means.
Okay.
All right, here we go. Ladies and gentlemen, we want to solve for all of the solutions, and the shortcut method for this is, well, there is a shortcut. You could add 64 and then take a cube root. That would only give you one answer. Okay. How many answers are there?
3.
3. The maximum is 3. 3 solutions. Okay. Whatever the highest power is, it gives you the number of solutions. So by isolating and taking a root, I'm actually losing some solutions. So I'm going to try factoring. And if you remember, this is difference of cubes. Difference of cubes. Difference of cubes. Had a small bubble and a big bubble. Small bubble, big bubble. Do you remember the signs for difference of cubes? Keep the sign, change the sign. Always positive. Very good, Eric. Okay. Now, what goes in our little binomial here? X and 4, because x times x times x gives me x cubed, and 4 times 4 times 4 gives me the 64. And then do you remember the pattern to fill in the other half? Square the first thing. That's right. Square the first, so x squared. And then what? 4. Yeah, multiply in the middle, so that's the 4x. And then square the, always positive. I'm sorry.
Yeah, I was like, what's going
Sorry.
on?
Square the last. Should always get you a positive value for that last one. Okay, because we have to get all 3 solutions, not just one. All right, so now that we remember that, that's why I did this one, because it's like, oh yeah, that was a while ago, right? Since it's set equal to 0, we're going to set each bubble equal to 0. So x minus 4 equals 0, which means what? X equals what? That was the easy answer.
Yeah.
Okay, yeah. But we also have x squared plus 4x plus 16 equals 0. Does this double bubble?
Yeah.
Never. Never. It will never double bubble. Okay. And so we have to use the quadratic formula. All right. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a.
Dang, I totally forgot.
All right. All right. So, let's see. 16 minus 64 is something. Negative 48. Does anyone have any questions about my 16 and my negative 64? It is I, yeah. So imaginary. This is why it doesn't factor, because it's imaginary. Let's see. I know 48 is 16 times 3, and there's a negative there. So how does the square root of negative 48 simplify?
4i radical 3.
Very good. So the negative gives us our I there, the negative under the radical. The square root of 16 is 4, and the 3 stays under the radical. And what is this 2 dividing?
Every time.
Each term. And the reason I split it up is because you will reduce it correctly when you do it that way. All right. Gesundheit. So negative 4 over 2 is negative 2 plus or minus 2i radical 3. Very good. My 4 and my 2 goes into 2 once, and 2 goes into 4 2 times. All right. There are all the solutions. 4 legs on floor, please, sir. Thank you. All right. All right, so that was difference of cubes. Keep the sign, change the sign, always positive there for those signs. All right, over here, you'll notice there are 4 terms.
Oh, that's pretty tragic.
How do you factor when you've got 4 terms?
You do
The red sea, yeah.
splits and
Factor by grouping,
Oh.
which was, part the Red Sea. I tell the whole story where greatest common factor over and over again is essentially what we're doing here. So when I look at the first 2 terms, they have something in common. What is their GCF?
x squared.
X squared. What's left behind when I take out the x squared?
X minus 3.
Okay. And then I have a GCF of the last 2 terms. Negative 4. Negative 4. When I take out the negative 4,
X. X minus 3.
x minus 3. Very good. And then we do it again. There are 2 terms here. They both have an x minus 3 in common. We ask for the GCF again. So I factor out the x minus 3. And then what's left behind?
X squared minus 4.
Uh-huh. Can anything else double bubble? Yeah. Oh, okay. So I have x minus 3, and then x squared minus 4 double bubbles into?
X plus 2 is x minus 2.
Okay, good. Now that was fantastic. What a good refresher, right? That's been a while, huh? And then we set each bubble equal to 0, which means that x equals? All right. X equals 3, x equals 2, and x equals negative 2. 3 real solutions.
Wow.
That's illegal.
That is illegal.
So, all of these solutions are real. Three real solutions.
Which one is not real?
No. 3 real solutions, which means that I could see them all on my calculator.
Oh, but imaginary one.
Exactly. So imaginary ones we can't see on our calculator. All right. So these you would be able to see on your calculator, and I just want to show you what it looks like because I think it's pretty cool. Quiet, please, you guys are too talkative. X cubed minus 3x squared minus 4x plus 12. And I'm going to draw that. It's kind of cool, right?
Why you do that?
That's what a cubic looks like. I'm going to change my window so you can see the top. My Y maximum, I'm going to make 15. Yeah, so what are you seeing here? These 3 solutions are where?
On the X.
On the X-axis, yeah. So here we're at negative 2.
2.
That's that one there. And then this one here is at
2.
positive 2. And this one here is at 3. All right. And so this is what a cubic function looks like. It's a squiggle. Okay. What do x squared functions look like?
Parabola.
Parabolas. Uh-huh.
Which, by the way, can there be a parabola that's kind of like, yeah, or like sideways, or like on the z-axis? It's kind of all weird, crazy like that.
Yeah, there's other equations that look like that. All right. Letter C, 2x to the 5th plus 3x to the 4th equals 2x cubed plus 3x squared. This is a very much higher order equation. Higher order, what do I mean when I say higher order?
More thinking.
More thinking. Higher order. Higher order.
Oh, there are more solutions.
He does not.
Higher order, higher powers. Okay. So how do you solve anything with like higher powers? Put it in your calculator.
Break factor.
Factor. Okay, before you can factor, what do you need to do?
Get it all on the same side.
Ah, very good. So set it equal to 0 is always a great starting point. So you want to move everything to one side.
So make the last two negative?
Yeah, so I'm going to move them over by subtracting. So that's 2x to the 5th plus 3x to the 4th, and then negative 2x cubed and a negative 3x squared, all set equal to 0. All right, and then what can you do? Factor by grouping. Yes? What else can we do?
I would say
Factor it all. You can factor out x squared from all of them.
Yeah, you can take out an x squared from all. There's an overarching GCF here. We have a GCF of x squared. So let's take that out first. If I take out the x squared, what's left behind? 2x to the 3rd plus 3x squared.
2x minus 3.
Very good. All right. Is equal to 0. Thank you for keeping the equal 0 on there. That's really important to us math teachers. And an equation starts with an equation and ends with an equation and an equation all the way in between. Okay. So now we do have the 4 terms, so we can factor by grouping again. And so I'm going to leave this x squared hanging out in front. And I'm going to look at the GCF of my first 2 terms here, which is x squared. And then what's left behind? 2x plus 3. Very good. And I'm going to look at the last 2 terms here. What's the GCF of those last 2 terms? Negative 1. Very good. And because you always have to take out something, you could always take out a positive 1. In this case, a negative 1. And then what's left behind? 2x plus 3, yeah. And then one more time here, we see they have a GCF. Here we have our greatest common factor of 2x plus 3. What's left behind?
X squared minus 1.
X squared minus 1. All these things are just being multiplied together, so maybe I don't need to write that. There it is. Yeah. All right. Yeah, x squared minus 1 does double bubble. X plus 1, x minus 1. Very good. All right.
X squared double bubble.
I'm
joking.
Yeah, no, it's not necessary.
2, 3, 4,
All
5.
right. So here I'm gonna set each.
X equals 0, 0, negative 1, and 1. And -3.
That's a good question. Okay, I see it. I'll answer it in just a second. So we set each thing equal to 0. So we get 2x plus 3 is equal to 0, and then x equals -1, and x equals +1. What does x equal here? All right, -3/2. Very good. What's going on here? X squared is equal to 0.
2 0 solution.
Yeah, so this is called,
That's what I'm saying.
we are going to take a square root. Normally, when you take a square, you'd have to have a plus or minus. So on a number other than 0, that's where your other two solutions would come from. The square root of 0 is 0. But normally, that's where you'd get your plus or minus. So you'd get 2 more solutions from that if it was a number other than 0. That's actually called multiplicity. It means it's hitting it 2 times. And that has a very interesting thing graphically that happens. Okay, so it's quite cool. It's called a bounce. At least that's what I call it. It's a bounce. It bounces. Oh, you want to see it?
Yes, we
Okay,
want to see
so
it. Yeah, show us how to find the answers to this equation. Now show us how.
Okay, so I'm going to go to this equation. So 2x to the 5th plus 3x to the 4th minus 2x cubed minus 3x squared. I'm going to zoom in just a little bit.
It's going to be a little crazy.
I'm going to zoom in again. All right, so you can see what's happening here. This is -3/2, and it passes through that 0, and then here we are at -1. It passes through that one, but at 0, when x is 0, it doesn't pass through. It's a bounce. It hits the intercept and then bounces back. It sort of returns.
So,
okay. And then it passes back through at x equals +1. All right. So that's what happens when you have that power. It gets repeated. It causes a bounce.
So if I don't answer, would there be 2 zeros?
We only need to write it once. Yeah.
oh wait, so it really only hits it once?
Correct. Yes, but graphically, it causes that bounce thing. So it's kind of an interesting thing. We'll talk a lot more about that. All right. Still a lot more to do today, ladies and gentlemen. Here we go. Oh, this is supposed to be equal to 0.
Oh yeah, we're on the.
All right, x to the 4th minus 12x squared minus 64. This has 3 terms. What should we do?
We should.
Double bubble. This is quadratic in form is what this is called. Which really, it's a trinomial, so we're going to try to factor. First times first has to be x to the 4th. What times what is x to the 4th?
X squared.
X squared times x squared. And then last times last has to be -64. What times what is -64? -8 and +8.
Yeah, -16.
-16 and +4. There we go. -16 and +4. All right. There. How do you know if you did it right? Check the rainbow. Okay. I'm just going to check really fast. 4x squared and -16x squared gives me my -12x squared. So I know I did it right. What can we do with x squared minus 16?
X plus 4x minus 4.
Good. Does this one double bubble?
Complete. Isn't there a square there?
Yeah.
Oh.
Yeah, it's just.
You cannot. Well, I guess I shouldn't say you cannot. You actually can. But I haven't showed you how to do that yet. This. What is the special name of this? Difference of squares. Difference.
There's no sums of squares.
Yes. Difference of squares, we can double bubble. Difference of squares will double bubble, but is this difference of squares? No, it is not. Okay. All right, so I'm going to set each bubble equal to 0. So I get x equals -4 and x equals +4. And the last bubble, x squared plus 4, gets set equal to 0. And then we have to solve for x. So what do we need to do? Subtract 4. So we have x squared equals -4. And then what can we do? Square root. Don't forget. Plus or minus. Don't forget the plus or minus. Yes. Plus or minus 2i. Very good. So you actually could have factored it. It could have been x plus 2i and x minus 2i. You can actually factor sum of squares if you use imaginary numbers. Not that I wouldn't really ask that, but it works. All right. All right. No, we're not done.
What?
All right, ladies and gentlemen. The last one was called quadratic in form. These are also quadratic in form. In form. And what that means is that they double bubble, just like this one did. It's not a quadratic equation because it's not x squared, but it's got 3 terms that we can double bubble. All right? So that's what we call quadratic in form. All right? It factors into bubbles. This also is quadratic in form. It's got 3 terms. And so you need to think hard here. Now I can show you this 2 different ways.
The easy way.
Easy way.
See, I can't answer that question because it's easy either way for me.
What's the shortest way?
Oh yeah, shortest way.
Well,
Shortest way.
well,
What's your favorite way?
How are we supposed to do it? Skip it and make some other problems.
no.
How about 3x?
Am I gonna run out of time here in a second?
Is it x 1/3 times x 1/3?
Yeah, it is. All right. So it's quadratic in form. I'm gonna go ahead and just stop this in